Hey guys, Mr. Enyart here with Mr. Enyart's Mathematical Compositions. This is grade 6, module 6, lesson 5 from Eureka Math, talking about histograms and relative frequency. So let's get to it. All right, lesson 5, we're talking about how data is distributed on a histogram, and we're talking about relative frequency. So if I were you, I would pause the video and I would write this down. But relative frequency is just what is the relevance of a particular item within the entire data set. That's how I think of it. So how frequent is this, let's say, extra small compared to everything else? And so that's simply a matter of a ratio. There's a total of 40, right, or a fraction. There's a total of 40, and only 2 of the times it was extra small. So the relative frequency of extra small is 2 out of 40, which is 1 out of 20, which is 0.05 or 5 hundredths. So the relative frequency is how relative something happens, how many times something happens based on the total amount of data or total frequencies. So I encourage you to try and fill this out on your own and then check back here. So pause the video, try and fill out the relative frequency column based on this information and see if you can answer these questions. Then play the video and check my answers. All right, so let's get into the answers. All right, so checking out our relative frequencies, these are the base fractions, amount out of the total, right? They could all be simplified, yes, but we're just going to leave them like that. And again, you can just plug this stuff into a calculator. If you don't have one, you would just do 15 divided by 40 in decimal form, and then it looks like we're going to stop at, and all of these did, but I would assume stopping in the thousandths place would be enough for pretty much any data. But pay attention to what it asks. Does it want it to the thousandths, the hundredths, the 10,000ths? So we end up with a 375 thousandths relative frequency here, 225 thousandths, 1/10, 5 hundredths, and that would add up to a total of 1, which is the whole, which makes sense because 40 out of 40 would be a whole, and we added 2 plus 8 plus 15 plus 9 plus 4 plus 2, which equals 40 out of 40. So combining all of your relative frequencies should always equal 1. So you can see I wrote that in here, and then the interval with the greatest relative frequency was our medium interval, which was, that was the size actually. I guess if I'm going to write the interval, I should write the 550 to less than 570 interval. This is the actual interval. And it was 3/8 or 375 thousandths. And then the percentage, now I want to break this down for a minute because there's a lot here. So our percentage of between 530 and 589, well, that starts here and ends here. So that was small through large. So I added up my 8, 15, and 9. This is just one way to do it. This is several ways. Is to add up your amount and then put it over your total. So 8 plus 15 plus 9 was 32. 32 out of 40 is 0.8 or 8/10. Now, another way to do it is simply add up your relative frequencies, right? Those are the same. 8 out of 40 is 0.2, 15 out of 40 is 0.375, and 9 out of 40 is 0.225. So when you add those together, you get 0.8. Now, we know that if we take the decimal form of a number and we multiply it by 100, which of course means moving the decimal twice to the right, we end up with the whole number that is our percentage. But even more I'm giving you is that we know that 8/10 is read 8/10, which could backtrack to 4/5, which is a benchmark fraction that I have put on our percentage to decimal video on Edpuzzle that we should memorize. That takes us to our decimal form and our fraction form to hundredths, because 80 hundredths, since percent is per 100, 80 is our percentage. So I know that was a lot, but feel free to backtrack through it. Just know that there's multiple ways to get this done. So I'm just going to go ahead and just throw these in at you so you can notice that what we have here is a histogram of relative frequencies from the histogram or frequency chart we already did in lesson 4. So this is it, head circumference in millimeters, right? Notice these intervals go by tens, while these go by 20, so that's why there's less bars, right? But this is the same data, just instead of frequency, It's relative frequency, which, as we've been learning, is the percentage amount or fraction of how much each interval is happening compared to the total. So when you look at the shape of this, it looks pretty normal. And when you compare it to the one from lesson 4, it didn't change at all, right? Even though they went from 10s to 20s and made this one with less bars, the shape is still normal. You just don't have this little sticking out part here because these two are combined into one bar. These two are combined into one bar, and so on and so forth. And as far as small, medium, and large go, just like we did on the previous exercise, it was 80%. And if you were to add all these right here, this is small, medium, large, right? And so here it was these two are small, these two are medium, these two are large. If you added all these together, you would end up with 32, and there were 40 total. And so you can get that data from the histogram, from the frequency chart, or you can simply combine, right? You can't really see the perfect percentage here, but if it was a computer and you could click this and see exactly what that number is, you could then just add the relative frequencies and get that percentage. Okay, so last one I want you to try. You don't have to try to do the histogram unless you feel like it. I will throw that on here for you to see, but at least try and fill out the relative frequency of the NBA basketball arenas that we did in lesson 4. Pause the video and go for it. All right, I'm going to go ahead and throw the answers down here. All right, so here are my relative frequencies. Feel free to pause and check all that. And I made the histogram here based on the relative frequencies. And I did what they did, and I combined them. I did 2 at a time. So this was 17,000 to less than 17,500, and then a separate one for 17,500 to less than 18,000. I just went from 17,000 to 18,000. So I just added 0.069 or 69 thousandths and 34 thousandths to get my answer here, which was just over 1/10. And then I combined these two to get this one, these two to get this one, so on and so forth. And so I really just want to focus on question F here from these. So this was our relative frequency histogram that we just made, right? And this was the frequency chart we made, the histogram we made for with just the regular frequency from the frequency chart of the exact same information. So do you see a difference in shape at all? If I were to, right? It looks the exact same, and it should, because they're percentages. And I even, narrowed it down by going from, 10 intervals to only 5 with combining them, or from 12 to 6, whatever. So here we are, that the relative frequency does not change the shape or outlook, but it does kind of make it look a little neater when you can narrow it down, and let you very quickly see the percentage of those higher amounts, because you're no longer having to count everything. All the counting's been done. So as always, go ahead and, if you are a journaler, which I sure hope you are, write down the definitions here for relative frequency if you haven't already, the example, and then go ahead and write this down as well, or screenshot and save it into your virtual notes if you have them. Then pause the video, try out the problem set, and check back with my answers here in just a moment. Okay, let's get into the answers. So I would say that this histogram is skewed right if you look at the shape, because the tail is going down to the right. I would say that the data shows me and the shape shows me that the maximum drop in feet is usually between 50 and 130, since that's where the bulk is. I could stretch that to 170 because after that they're pretty much outliers. I would love to go on this roller coaster, or however many roller coasters were out there. But these are the extreme roller coasters, right? The super tall, maybe they're on top of buildings or something. And then as far as him claiming that 50 to 130 feet is more than half the data, yeah. Because 60% is greater than 50% and 50% is half. So what I did was I took the about, this is about 27 and a half, this is about 32 and a half. Even if I rounded down, I would still end up over 50%. As to how many are there. Remember, these relative frequencies are the decimal forms of the percent that you would be between these intervals, right? So a little more than 25% here, a little more than 30% here, but not quite 35. And so these decimals are the decimal forms of percentages that these happen. All right, and to wrap it all up, here is our frequency table filled out with a total of 28 just by counting up the total of frequencies and rounded to the nearest thousandth. That's important. So our percentage of lengths that are greater than or equal to 130, I had 4. It's these ones right here out of 28, which is 0.142 or 14.2% there. And I drew the frequency chart, which had a normal distribution, as you can see by my outline here. And so based on that shape, I would say that our length of movies are typically between 100 and 130. Then for the bottom, here's the frequency chart, also rounded to the nearest thousandth, as it said here, with a total of 16 happenings, or cars, different compact cars, that we are comparing mileage of. And so the percentage of the ones that get between 31 and 37 there were 9 of those out of 20, or out of 16, and 9 divided by 16 gave me 0.5625, which is 56.25%. And lastly, he did not draw the histogram correctly. It looks absolutely perfect up to here. This is right, this is right, this is right, this is right. We have miles per gallon down below. We have relative frequency. It's all divided equally and looks nice. Nice title. But from 40 to 43, as you can see up here, was 0.063. But then from 43 to 49, I had zeros. And he doesn't even go to 52. He has from 43 to 46 being 0.063, and that's not correct. There should be 2 zeros, 2 more intervals with zeros continued, and then from 49 to 52, that's where he should have the 0.063.